Now that we've looked at segmentation, we're going to look at more complicated cluster analysis. Now, before we do this, I just want to state that just because segmentation is simple, male, female, married, single, etc., just because it's simple doesn't mean it's bad. It's actually quite good. The thing is that a lot of companies do that. So if you want to have a competitive advantage, you have to expand your clustering to complex clusters. So we're going to just take a quick overview of the theory, then we'll give some examples. So clustering. This is segmentation, but we're now going to use multiple continuous variables. Usually clustering is difficult. It's difficult to do this. That's why people don't do it. It's not technically difficult, but it's difficult to find good clusters. It usually will require advanced mathematical techniques. We're going to have to use specialized software. Fortunately, R is pretty good at this. Most competitors, if you own a company, most of your competitors do not do this type of clustering because it's difficult, time-consuming, and expensive. So this is why you're going to want to learn how to do cluster analysis. Now, there's many types of cluster analysis. Probably the two most widely used are k-means clustering, and the second one is self-organizing maps, sometimes called Kohona networks. We are going to only look at k-means clustering since it's by far the most widely used and it's also the most simple. So we're going to look at that. Now, rather than explain the k-means algorithm, it's complicated. An example will show you more clearly what's going on. So let's look at this data set here. So you can see we have each dot as a data point. And if you look at this as a human being, you would say, well, how many clusters do you see? Well, it's very easy to see that there's 3 clusters. What makes a cluster? Well, the data in a cluster is all very close to the other guys in the cluster, and they're far away from everybody else. So we've got 3 clusters here. Now, let's pretend that we know ahead of time that there are 3 clusters. Now, we're going to talk about how you know how many clusters there are, but let's just say ahead of time we know that there's 3 clusters. Well, how do we find those? Well, what you do is you would start off with random starting points. Now, these are hardly random. I just put one on top of the next. But let's say we've got a blue cluster, a green cluster, and a red cluster. You start off with a random starting point. And what we do is we put every point to the closest cluster it can find. So this guy is closest to blue. So he would be in the blue cluster. Over here, we have this guy is closest to red, so he would be in the red cluster. And this guy here is closest to the green, so he would be in the green cluster. So if we assign everybody to the closest cluster, you could see all of these guys are closest to blue. All of these guys are closest to green, and all of these guys are closest to red. So what we do next is we move the center point so that it's in the middle of the cluster. So of all of these blue guys here, this guy would go into the middle, which would be about right here. This guy, a lot of the green guys are over here and a couple are over here. So this guy would kind of move over here a little bit, and there's a lot of red guys over here and a lot of red guys over here. So this guy would kind of move over here. So the next iteration is we have them move to the center point. But once we move them, then suddenly, if you notice, this guy, for example, was closest to the blue. But once he moves over here and this green guy moves over here, he's closest to the green. So you'll notice that as we move these guys, this guy is now closer to the green than he is to the blue. So he becomes green. And the red guy kind of stayed, all the red guys didn't do anything. So now this blue guy he doesn't have as many over here. So he's going to say, well, I'm closer to these guys. So he's going to kind of move over here. This green guy is going to have all these green guys over here, couple over here. He's going to probably move over here somewhere. The red guy will probably stay right where he's at. And there you go. Now, this blue guy is getting closer over here. He's got some of these and he's got some of these, or he's got this guy. This green guy is going to move over here. This red guy's got a couple of here and a couple over here. So now the green guy moves here. The blue guy moves over into this cluster. He's still got here. This red guy's got some of here. We move them again. And then eventually they move and they stop moving. And these are our three clusters. So that's the process. It's an iterative process, and we keep moving the centers around until they stop moving. And that is where we find our clusters. Now, how do we translate this into the real world? Okay, so let's look at this with customer data. So usually what we'll do is we'll take and we'll do k-means clustering, and we're going to look at multiple variables simultaneously. And this will allow us to do more sophisticated treatment of our customers as opposed to segmentation. Where before we were looking at married and single and male and female. That gives us some stuff to do, but now we can do more with clustering. So for example, let's say, now you don't have to do just two variables, we can use many, but let's just look at income and let's look at age. And you can see these are all data points over here. And you can see we've got there young people who don't make a lot of money, we've got old people who don't make a lot of money, middle-aged people, they don't make much money, and these people are middle-aged and they got lots of money. Okay, so these are, let's say you're a bank. Okay, so what would we do with this? Now, as opposed to, let's just assume that we've run a clustering algorithm on this data set. And if we do this, an algorithm would say, okay, it's found 4 clusters. And if we name these clusters, we might say, well, okay, here are young people who don't make a lot of money. We might call them recent college graduates. So there they are. And we might say these people are middle-aged and they make lots of money. This is peak income earners. What about these people? They're middle-aged and they don't have any money. Well, they might be unemployed people. And these are old people who don't have any money. They might be retired. So we've got 4 distinct clusters. Now, what do you do with that? Well, we might decide that we're going to use these customers for cross-sell purposes. In other words, let's sell them something that they might want. Okay, recent college graduates. Okay, well, a recent college graduate, once I know that you're a recent college graduate, you don't want a mortgage because you don't have any money. You're not buying a house. So that person here is, the only thing they care about is they don't have a lot of money. And so they constantly are bouncing checks. So you give them overdraft protection. They'll pay for they don't get hit with a fine. They might go for overdraft protection. What about our peak income earners right here? These are the people who want mortgages, home equity line of credit, investment accounts, lots of stuff, financial instruments. That's what they care about. Retired people. These are people who want to set up trust funds, retirement accounts, estate planning. This person here isn't going to set up a trust fund. Trust funds are very profitable for a bank. But why would I ever try to sell a trust fund to a recent college graduate? They don't have any money. They don't care about that. So what we're going to do is you are going to we're going to market the right product to the right customer. Now, what about our unemployed people? These guys right here, they don't have any money and they're unemployed. So it may not sound real nice, but marketing purposes, you might call those choose to lose. In other words, they're just costing you money. Or maybe they're not costing you money, but they're not really worth much to you. So you don't care one way or the other. If they get a job and they suddenly have a lot of money, then maybe you start treating them differently. You don't have to be a jerk about it, but you could certainly, this is certainly a group of customers who are not profitable. So this is where segmentation or clustering can become very useful. Now, what if you're saying, well, big deal, what if we just look at how much money they make? Well, okay, we could do that. We could just look at the amount of money they make. If we look at only one variable, well, we would have two clusters. We'd have high income and low income. But you can see that we have here that the recent college graduates, the unemployed people, and the retired people are all low income, but they have clearly different needs. But what about if I just look at your age? Well, young people and old people have different needs than the middle age, but here we have the peak income earners and we have the unemployed people. They have clearly different needs. So if you only use one variable for your clustering or your segmentation, then you're clearly missing out on some valuable information. That's why clustering is so powerful. It allows me to merge two variables together and learn something new. So this is a trivial example because, again, you could have just eyeballed this and figured this out. So most clustering is not going to be as straightforward and obvious as this. If it were, everybody would be doing it. Most clusters will usually use two or more variables, and you can't usually visualize like 3, 4, 5 variables. It's harder to see. Also, this data is compact and well separated. This data is all grouped together and it's far away from everybody else. The data in the real world is not so clear cut. So also, there's one other thing that you need to know about clustering is that it doesn't always converge to a good cluster. Let me give you an example. So remember this data before, it converged to a very nice cluster. Our clusters. But what if we started somewhere else, like right here? If we followed the same logic that we followed before, you can see here that these clusters converge to bad clusters. This one here, this is an obvious cluster, and this is an obvious cluster, and this is, but you can see that the starting point can sometimes affect the quality of your clusters. So the point is that this is why a lot of times corporations don't do a lot with clusters, because if you don't know what you're doing, you can end up with bad clusters. And I'm going to show you some techniques to get good clusters. So anyways, the summary is that our clusters can be very useful, but one caveat for you is that your cluster starting point can affect the quality of our clusters. So in our subsequent lectures, we're going to actually try to do this in R, and we're going to explore some of the techniques for developing clusters.